Today we'll continue our exploration of quadrilaterals. We'll talk about how the properties of rhombi or rhombuses, rectangles, and squares all interact with the perimeter of a quadrilateral. All quadrilaterals have four sides, four angles. So these are all examples of quadrilaterals. Quadrilaterals within them have different categories based on the sides and the angles, namely how congruent or not congruent they are. All of the interior angles of quadrilaterals, all quadrilaterals, add up to 360 degrees. So when you add up those four angles, you get 360 degrees. All quadrilaterals have these properties. There are more specific properties for more specific quadrilaterals. One such category of quadrilaterals, parallelograms. A parallelogram is a quadrilateral that's composed of two sets of parallel lines. So if we looked at it as just parallel lines, it makes a shape. These parallel lines create a certain set of properties for parallelograms. First off, opposite sides are congruent and parallel. So those two sides are the same measure, they're congruent. These two sides are the same measure, they're congruent. Opposite angles are also congruent. Those two angles are the same measure, those two angles are the same measure. When we have a parallelogram, we can find its perimeter, just like any shape, by adding up the sides. However, in the case of a parallelogram, we don't always have all four sides. We can use those properties in order to find the missing sides. So in this case, I have one side is 6, one side is 5. I know this is a parallelogram. With all parallelograms, opposite sides are congruent. So those are both 5 centimeters. These opposite sides are congruent, so these are both 6 centimeters. I went from having only two sides to now knowing all four. Once I have all four, I can just add them up. 6 plus 5 plus 6 plus 5, well, that's 11 and 11. That's 22 centimeters. Make sure the unit goes with. It's very important. So with area, we only need two of the measurements, two very specific measurements. With a parallelogram, in order to find the perimeter, we need to find all four using those properties. Rectangles are a very specific kind of parallelogram. They're parallelograms with four right angles and two pairs of opposite congruent sides, just like all parallelograms. So opposite sides are congruent and parallel. That's no different than parallelograms. But all four angles are congruent. They're the same. So if I take 360 degrees and divide it evenly by 4, I get 90 degrees. These are all right angles. Using these properties, we can help to understand or help to find missing sides. So that way, when we have a problem like this and we need to find the perimeter, we can't just add all the sides that are given. 6 plus 3 would only give us half of the perimeter. But I do know that I can use my properties. Those opposite sides are congruent and parallel. So I know that this is 6 inches because it's congruent to the 6 inches on the other side, and this is 3 inches because it's congruent to the 3 inches on the other side. Now I have all of my sides and I can find my perimeter. 6 plus 3 plus 6 plus 3 gives us 9 plus 9, or 18 inches. Just a matter of adding it up. Another variation on finding the perimeter of a rectangle would have you multiply the base by 2 and multiply the height by 2 and then add those together. If you look at the current formula, which is just adding up all the sides, I see 6 in there twice, which is my base, and I see the height 3 in there twice as well. So you could either multiply the base times 2 and add it to the height times 2, or use your properties to find all the sides and add them up. It's probably the most straightforward method. For rhombuses or rhombi, a parallelogram with four congruent sides. So all sides have the same exact measure. Those two are congruent, and those two are also congruent. If one of those sides is 6, all four sides are 6. The opposite angles are still congruent, just like all parallelograms, and these properties help us to figure out things like angle measures, things like side measures and perimeter. So we have this example right here. We have one side that is 4 meters. This is a parallelogram and a rhombus. So all sides in this case are congruent. So if I know that this side is 4, I need to use my properties of a rhombus to find all 4 sides. There's 4, there's 4, and there's 4. All sides have the same exact measure. Now, since all 4 sides are the same, I could just multiply that one side by 4 or add up all of the sides. That's the most consistent way of finding the perimeter. Find all your sides using your properties and then add them all up. 4 plus 4 plus 4 plus 4 gives us 8 plus 8. 8 plus 8 is 16. Again, with a rhombus, I can multiply one side by 4 to find the perimeter. That would still give us 16 meters, as 4 times 4 is 16. A square is a very specific parallelogram. It's a parallelogram with 4 right angles and 4 congruent sides. So all of my sides are congruent. All 4 have the same exact measure, same exact distance. All of my angles are congruent, which means they're all right angles. This is because, even though a square is a parallelogram, it's also a rectangle. This is where we get the 4 right angles. Not only is it a parallelogram and a rectangle, it's also a rhombus because it has all 4 sides congruent. So a rectangle is a quadrilateral parallelogram rectangle / rhombus. It's a very specific set of properties. If I want to find the perimeter of a square, I just need to add up all the sides. In this case, I may not be given all 4 sides, so I have to use my properties. So the properties of a square is that all 4 sides are congruent. If I know that that side is 8, then that side is 8, that side is 8, that side is 8. Just like a rhombus, we can multiply one of the sides by 4 to get our perimeter, or add up all the sides. 8 times 4 is 32 feet, or 8 plus 8 plus 8 plus 8 is 32 feet. It's important to understand how these properties come about and how these different shapes are organized. All of these shapes are quadrilaterals. They all have 4 sides, like we've discussed. There's a certain subsection of shapes called parallelograms. Those exist only when they have 2 pairs of parallel sides. This creates a certain set of properties. All opposite angles are congruent. All opposite sides are congruent, and that's the case for all parallelograms. We can break parallelograms down into even more specific shapes. Here we have rhombuses. The key property with rhombuses, or rhombi, is that it only has one side measure. All 4 are congruent. So if I know one of the sides, I know all 4 of the sides. We also have rectangles. Rectangles, just like rhombuses, have one measure for the angle because all 4 angles are congruent. So if I know one of my angles, I know all 4 of my angles. And they're always going to be 90 degrees because the interior angles are 360. We break that evenly 4 ways, we get 90 degrees. In the middle, where rhombuses and rectangles meet, we have one specific shape. A shape that's a quadrilateral with 4 sides. It's a parallelogram because the opposite sides are parallel. It's a rhombus because all 4 sides are congruent. And it's a rectangle because all 4 angles are 90-degree angles. That's our square. Using and understanding these individual properties helps us find missing sides, missing angles, and that helps us determine the perimeter, the area, and any missing values that we may need to find within any of these quadrilaterals.